Zai, a very good morning to each and every individual watching the tutorial. Now, this tutorial is on the chapter called expansions. Okay, so right now we'll not be dealing with the entire formulas. We'll just be dealing with the few basic formulas of your expansions that we need. We have plenty of other formulas also, but right now we'll just deal with these four formulas. Okay? So the first formula that I think everyone is aware of is this. So we have a plus b whole square formula. We read this as a whole square. So that is equal to a squared plus b squared plus 2ab. Similarly, we have for a whole square, but if I have a minus in the middle, then it is a minus b whole square. The formula is still the same thing, a squared plus b squared. But over here, if it is a plus, we'll have a plus 2ab. But if it's a minus, we'll have a minus 2ab. And then we have two other formulas for your cubed. Okay, we have the same a plus b, a minus b, but now the powers is not a square, it's a cube. So if I have the powers as a cube, then we have the exact same formulas for both the cubes. Okay, it's just that wherever I see a plus, everything will be a plus. So we have the plus a plus b whole cube formula as a cubed plus b cubed plus 3ab bracket a plus b. And the same thing for your a minus b whole cube. It's just that wherever I see a plus, I'll have to put a minus. Okay, and sometimes the junior classes and all, okay, what they do is, so they may get confused with a and b, because at times certain questions will have a also written over there, so they tend to get a little confused. So what you can do is the same thing you can write as this one. So instead of a plus b whole square, what you can imagine it to be as a first plus second whole square. So a we consider as the first, b we consider as the second, and then it becomes first square, that is a square, plus the second square plus 2ab means 2 into first into second. Same way the second formula, the third formula, and the fourth formula. So wherever you see an a, you can imagine it to be as the first. So if you want, you can learn the formulas as this. But in general, what we do is we always say the formulas in terms of a plus b, a minus b, all that stuff. Okay, but if someone feels that, okay, you may get confused, you can still use the first plus second and the first minus second, the first plus second whole cube, first minus second whole cube, and all. So let's go ahead and show you a few questions where these formulas will be applicable. Okay, for example, so let's say, for example, if I have a question where it says expand a 2x minus 3y whole square. Now whenever I see such a question, now what will happen is that first thing, if I want to solve this, I'll have to check which out of these four formulas will be applicable over here, and whichever is applicable, we'll just have to apply that. Now how do I figure it out as to which of the four formulas will be applicable in this one? All we have to do is, first thing is check what's the power that is given to you in the question. The power is a 2, so 100% we'll have to go ahead and check for the formulas which has a power 2. So these two, they have a power 3, so that means these two formulas will not be applicable 100%. It's either the first formula or the second formula will be applicable, because they are the ones that have the power 2. So that's the first thing I check. So now I have two options, either this formula or this formula. Now how do I verify which is the correct formula that we need to apply? So for that, the second step is you need to check the sign in the middle. So what sign do we have? We have a minus. So we check out of these two formulas which has a whole square, which has a minus. So this has a minus. So 100% the second formula is what will be applicable in this question. Okay, so now over here the formula says first, second, but over here we don't have a first, second. So what is the first over here? So if you look carefully, the first is this. So that means the first over here is my 2x, and the second over here is my 3y. So in the formula, wherever I see the first, now we'll have to replace that by a 2x, and wherever I see a second, I'll have to replace that by a 3y. And whenever I have more than one term, I always put it in advisable, we always put it inside a bracket. So now the formula says first square. So what is the first? 2x. So 2x square plus, it says 3y square minus 2 into the first into second is 2 into 2x into 3y. Now this square is for 2 also, this square is for x also. So indirectly 2x square means it is 2 square x square. 2 square, everyone knows it's a 4x square. So that's how we get a 4x square, plus this square is again for 3 and y, so it's 9y squared minus. Now when I want to solve this, the numbers, they get multiplied. First multiply these two, we get 2 2s are 4. Then the answer will again multiply this number, 4 3s is 12. That's how we get a 12, and x into y gives me an xy. So that's how we go ahead and solve this. So let's give you another example. So now let's say it's 2x minus 3y whole cube. Now again I see a cube, so 100% either this or this formula will be used. Now to verify which is the correct one, what is the sign in the middle? That is minus, so this formula will be applicable. So now if I look closely, again, what is the first over here? The first over here is your 2x, and the second over here is your 3y. So wherever in the formula I see a first, I'll have to put 2x, and wherever I see a second, I'll have to put a 3y. So the formula says first cubed minus second cubed. So what is the first over here? 2x cubed minus 3y cubed, minus, the formula says 3 into the first into the second. So it says 3 into the first into the second, and then we have a bracket which has a first minus second in the formula. So we have a first minus second. So that's the formula we will use. And then now this cube is for 2 also, this cube is for x also, so then it becomes 2 cubed x cubed. Again, this cube is for 3 also, y also, 3 cubed y cubed. And then just now we explained how do you multiply. 3 2s are 6, 6 3s will give me an 18, x into y gives me an xy, and 2x minus 3y as it is. Now 2 cubed, everyone knows, is 2 into 2 into 2. It's not 2 into 3. So 2 into 2 into 2 will give me an 8. 8x cubed minus 3 cubed will give me a 27y cubed. Now when I multiply this, so indirectly in the rough, it's like 18xy getting multiplied with 2x. First the sign. So indirectly it's like minus 18xy is getting multiplied with the plus 2x, because you have a plus 2a. So minus into plus will give me a minus. 18 into 2 will give me a 36, because there is a multiplication. Now x into x gives me an x square, and the y as it is. So we get minus 36x squared y. In a similar manner, 18xy will multiply this. So minus into minus gives me a plus, and then 18 into 3 is 54x square, xy square. That's how we solve. Another example. So let's say now we have something like this, okay, a fraction. So now this is the first, and now the entire 1 by 3x is the second. So the first over here is 3x, and the second over here is 1 by 3x. So the same formula, the cube's negative formula, but wherever I see an x, now we'll have to, first we'll have to put this. So it's first cubed minus the second cubed minus 3 into the first into the second, bracket first minus second. That's the formula. Now this cube is for both of them, 3 cubed x cubed. Now this cube is for 1 also, for 3 also, for x also. So we write 1 cubed 3 cubed x cubed minus 3. And then now, how did I get the 3? Now over here, this is all multiplication. Now when you're multiplying, what will happen? If you don't have anything, you just put a 1. You don't have anything, just put a 1. And then the numerators multiply each other and the denominators multiply each other. But before multiplying, you try and check if there is anything between them that can be cancelled. So when will the cancellation take place? Provided there is no plus minus in between. Like over here, we have a minus. Okay, so this 3x and 3x will not get cancelled. But over here, if I monitor this group closely, there are no signs between them. It's all multiplied. So over here, if I have anything that can be cancelled, then we just go ahead and cancel, like 3x and 3x is cancelled. So what are the leftovers? We have 3 and 1 in the numerator. They get multiplied. 3 into 1 give me a 3. 1 into 1 give me a 1. And this as it is. Okay. And then this 3 cubed is like 27, and x cubed minus 1 cubed is 1. 3 cubed is 27. X cubed minus. Now again, just like over here, when we are opening the bracket, whatever is in the front, that multiplies the first term. Same thing over here also. Whatever is in the front, this will first multiply this. Now, if you have nothing, means you can put a 1. So these two will get multiplied. So in the rough, it's like minus 3 by 1 into 3x by 1. If anything can be cancelled, cancel. If it can't be cancelled, then you simply multiply the numerators and the denominators. So nothing can be cancelled. So 3 into 3, the numerator gets multiplied with the numerator. So we get a minus 9x. 1 into 1. If you want, you can put a 1. Okay, and then similarly, now this one will multiply this, so it's like minus 3 by 1 into minus 1 by 3x. Now if you want, you can first only cancel over here. Okay, but over here I did not cancel. I just wrote minus into minus. I wrote a plus. 3 1s are 3 divided by 3x. So this is one extra step I've done. Okay, but if you think, no, I'll cancel it over here only, I don't want to waste my time writing this extra step, then you can just cancel over here. Minus and minus gives me a plus, and there is nothing, means 1 into 1 will give me a 1. Down is x into 1 will give me an x. So that's how we go ahead and apply these formulas. Okay, so these are quite simple ones.